Discount Sounds has 260 retail outlets throughout the United States. The firm is evaluating potential location for a new outlet, based in part on the mean annual income of the individuals in the marketing area of the new location. A sample size of 36 was taken. The sample mean income is $31,100. The population is not believed to be highly skewed. The population standard deviation is estimated to be $4,500, and the confidence coefficient to be used in the interval estimate is 0.95. Because 1 minus alpha equals 0.95, and there are two tails in an interval estimate, we need to find the values of negative z and z that correspond to left and right tail probabilities equal to alpha divided by 2, or 0.250. Because the population standard deviation is known, and we have a sample size of 36, and the population is not highly skewed, we can use the standard normal table. So we locate 0.0250 in the standard normal table, which is in row negative 1.9 and column 06. Because the probability that z is less than or equal to negative 1.96 equals 0.0250, and the normal distribution is symmetric, negative z equals negative 1.96, and z equals 1.96. Thus, plus or minus z subscript alpha divided by 2 is equal to 1.96. The margin of error is equal to z subscript alpha divided by 2 times the standard deviation of the sample mean, also known as the standard error of the mean, which equals 1.96 times the population standard deviation of 4,500 divided by the square root of 36, which equals 1470. Thus, at 95% confidence, the margin of error is 1470. And so the interval estimate of the population mean mu equals the sample mean of 31,100 plus or minus the margin of error of 1470, which corresponds to a lower endpoint of 29,630 and an upper endpoint of 32,570. We are 95% confident that this interval estimate contains the population mean mu because if we randomly sample the population, say 1,000 times to construct 1,000 interval estimates, 950 of them, or 95% of them, will contain the population mean, mu.